Have you ever looked up at the night sky and wondered, what's really out there? What if I told you that everything we see, the brilliant stars, the swirling galaxies, even you and me, is just a tiny, insignificant fraction of what truly exists? Brace yourself, because we're about to journey into the shadows of the cosmos, to uncover a mystery that could change everything we know about the universe. This is the story of dark matter. For centuries, humanity believed that what we saw was what we got. Our telescopes revealed a glowing cosmic masterpiece filled with stars, planets, and nebulae. We thought we had a pretty good handle on the inventory of the universe. But then, in the 20th century, astronomers noticed something deeply strange, something that didn't fit our perfect picture. Galaxies were spinning too fast, way too fast. According to the laws of physics and the amount of visible matter we could see, these massive star cities should have torn themselves apart, flinging their stars into the void millions of years ago. But they didn't. Something unseen, something incredibly massive, was holding them together with an invisible iron grip. They called this mysterious substance dark matter. Imagine this for a second. Over 85% of all the matter in the entire universe is completely invisible. We can't see it, we can't touch it, and we can't detect it directly with any of our instruments. Yet, it's everywhere. It's surrounding us right now, passing through our bodies, shaping the galaxies, bending the very fabric of space-time, and silently controlling the destiny of the universe. So what exactly is this cosmic ghost? Well, that's the billion-dollar question. We know what it's not. It doesn't emit light. It doesn't absorb light. And it doesn't reflect light. It is utterly, perfectly black. But its gravitational fingerprint is undeniable. It's the cosmic glue holding galaxies together, the invisible skeleton upon which the entire universe is built. Here's where it gets really mind-blowing. Scientists estimate that this invisible dark matter makes up about 27% of the total mass and energy content of the cosmos. Meanwhile, everything we can see, everything we've ever studied, all the stars, planets, asteroids, comets, gas, dust, you, me, everything, makes up less than 5%. Let that sink in. Most of the universe is effectively missing from our view. Our first real clue came in the 1970s, thanks to the pioneering work of astronomer Vera Rubin. She was meticulously studying the rotation of galaxies, plotting how fast stars moved in their orbits. She expected the stars on the outskirts to move much slower than those near the center, just like the outer planets in our solar system orbit the sun more slowly than the inner ones. But that's not what she found. The outer stars were moving just as fast, if not faster, than the inner ones. Her data simply didn't add up. It was as if they were being pulled along by some immense, unseen halo of mass. This powerful invisible force, dark matter, instantly became one of the greatest and most profound mysteries in all of science. Ever since Rubin's discovery, scientists around the globe have been on an epic quest to unmask its true identity. They've built enormous, incredibly sensitive detectors deep underground, shielded from the constant barrage of cosmic radiation, hoping to catch a rare, fleeting glimpse of a dark matter particle bumping into a normal one. The leading theory for a long time was that dark matter is made of WIMPs, which stands for weakly interacting massive particles. These are hypothetical particles that are heavy, but barely interact with normal matter, which would explain why they're so hard to find. Other theories suggest it could be something far stranger, like incredibly lightweight particles called axions, or even primordial black holes forged in the fiery chaos of the Big Bang itself. But here's the twist. Despite decades of relentless searching, despite building ever more sophisticated experiments, we have never, not once, directly detected a particle of dark matter. It seems to pass through everything, the Earth, buildings, even you, without leaving so much as a whisper. Yet its effects are all around us, written in the very structure of the cosmos. So if we can't see it or touch it, how can we be so sure it's there? Today, we use some of the most advanced telescopes ever built, like the Hubble and the James Webb Space Telescope, to map its presence indirectly. We do this by observing a fascinating phenomenon predicted by Einstein: gravitational lensing. Because dark matter has mass, it has gravity, and that gravity warps the fabric of space-time. As light from distant galaxies travels toward us, it passes through these invisible clumps of dark matter. The gravity of the dark matter acts like a lens, bending and distorting the light. By carefully studying how this light is warped and twisted into arcs and rings, astronomers can literally map the invisible. They can trace the presence and distribution of dark matter across billions of light years, creating a 3D map of the universe's unseen architecture. And the deeper we look, the stranger and more beautiful it gets. Powerful computer simulations of the early universe show that dark matter was the first thing to clump together after the Big Bang. It formed a vast, intricate network of filaments and nodes stretching across the entire cosmos, something we now call the cosmic web. The ordinary matter we see, the gas and dust that form stars and planets, was then drawn by gravity into these dark matter filaments like pearls gathering on an invisible string. The galaxies we see today are located at the intersections of this grand dark structure. Without dark matter to act as this initial cosmic scaffolding, there would be no galaxies, no stars, and no life. It's the invisible foundation of our existence. But wait, the story doesn't end there. If dark matter is the cosmic force pulling the universe together, scientists discovered another, even more mysterious force that's doing the exact opposite, pushing it apart. They call it dark energy. Together, dark matter and dark energy make up a staggering 95% of the total energy density of the universe. All of visible matter, everything we've ever known, every discovery we've made, every galaxy we've ever seen, exists within that tiny remaining 5% of reality. We are just the cosmic crumbs in a vast, dark ocean. The rest of reality remains hidden, forever beyond the reach of light itself. Scientists now believe that unlocking the secrets of dark matter is the key to the next great revolution in physics. It could rewrite everything we thought we knew. Finding it could reveal entirely new forces of nature, undiscovered particles, or even hint at the existence of extra dimensions. Some tantalizing theories even speculate that dark matter could be a bridge to parallel universes, invisible worlds coexisting right alongside our own, interacting with us only through the subtle pull of gravity. So, where do we go from here? The hunt continues, more intense than ever. All around the world, ambitious experiments like the Xenon T detector in Italy and the LX Zeppelin experiment deep in a former gold mine in South Dakota are pushing the limits of technology, listening silently in the dark. The hope is that one day, just one of these elusive, invisible particles will finally bump into one of their detectors, betraying its existence and giving us our first real glimpse into the unseen half of the cosmos. That single event would change science forever. Until that day comes, we keep looking up at the night sky. We look not just to marvel at the brilliant lights we can see, but to contemplate the profound darkness we can't. Because sometimes, the most powerful and fundamental forces in the universe are the ones that remain completely invisible. So the next time you gaze into the star-dusted darkness, remember this. The universe is mostly dark, mostly unknown, and yet, that very darkness is what holds everything together. The mystery of dark matter isn't just about the vastness of space. It's about discovering the hidden, fundamental truth of existence itself. Thanks for joining me on this journey into the dark. If you enjoyed this cosmic mystery, don't forget to like this video, subscribe for more adventures into the unknown, and hit that notification bell. See you next time.